Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Scale Drawings. Alright, take a look at this with me as I read these sentences out loud. A scale drawing is a reduced or enlarged drawing of a real object. Each measurement on the scale drawing is proportional to the corresponding measure of the actual real object. The most common scale drawings that we see in real life are maps and blueprints, which is what these guided notes are going to be focusing on. Blueprints, in case you're not sure what those are, they are technical drawings of something that will be built, such as the floor plan of a building. They are printed in white ink on blue paper, which is where the name blueprint came from. Now, there's also a thing dealing with scale called scale models. It's not what these guided notes are going to focus on, but they are a real thing. They are physical models of the actual real objects. And so instead of drawings done to scale, they are models created to scale. The following images here are not on your guided notes. Here we can see a model that is made to scale of a helicopter. And then here you see a picture of the actual real life helicopter. So again, still the same idea, things created to scale. It's just that our guided notes are going to be focusing on scale drawings, not so much scale models. Okay, so what is scale? I keep talking about scale. Scale is the ratio of a given length in a drawing or in a model to the length of the actual real life object. For example, the scale on a blueprint is 1 inch equals 4 feet. Now, this is not always going to be the scale on blueprints, but this is typically the most common scale that seems to be in real life for blueprints. The number on the left is the drawing measurement. The number on the right is the actual real life measurement. So what this is telling you is every 1 inch of length on the blueprint is corresponding to 4 feet in actual real life for whatever this blueprint is created for. Okay, let's look at some actual examples here. Here we have a map. Let's read the problem together. It says the distance between Hagerstown and Annapolis, these are both towns in Maryland, on the map is 4 units. You're like, what's a unit? Well, let me get out my highlighter here. Down here you can see how long a unit is. And they're telling you every 1 unit is equal to 24 miles. So right down there in the corner of the map is the scale. And this is very common in maps, that in one of the corners of the map, you will see a scale. If you ever use Google Maps or something like that, and you zoom in and zoom out, the scale in the corner will change as you zoom in and as you zoom out. It's not always going to be in the bottom left-hand corner, but it's going to be in a corner somewhere on a map. Back to the problem. What is the actual distance between the cities? So we don't want to just say 4 units. We want to find out what is that actual distance in miles. How do I know that they're talking about miles? Because I can look here on the actual scale in the corner of the map, and I can see 1 unit is 24 miles. So here's what you can do. You can use the idea of proportions, where you can make the scale one of the fractions of the proportion. Go ahead and write this down. We know 1 unit corresponds to 24 miles. So 1 over 24. And we're going to set that equal to 4 units. So since the 1 unit was on top here, the 4 units given to me in the problem will also be on top in the numerator. We got to set up both fractions the same way. Units on top, miles on the bottom. Unknown miles is what we're trying to solve for in the bottom. Now, you could solve this proportion by cross multiplying, but sometimes there's a shortcut. How do I get from 1 to 4? I would multiply by 4. Go ahead and write this down with me. So likewise, if I would do that in the numerator, then I can do that in the denominator as well. And then the only thing you really have to do in your calculator is 24 times 4. Go ahead and do that right now. 24 times 4. And the answer for x is 96 miles. So that is the actual distance between Hagerstown and Annapolis, according to this map. Now, maybe in real life it's not exactly 96 miles, but pretty much. That's what our answer is. Now, you might be like, Mr. Underkoffler, wait a minute. Do I really have to show a proportion? Couldn't I really just do the 24 that the map gave me here for the actual distance for 1 unit and multiply it times 4 because it was 4 units? Yeah, you actually could. That is the shortcut. Go ahead and write this down on the side of your work here where it's labeled shortcut. 24 times 4, we know the answer is 96. You might be like, Mr. Underkoffler, can I use this shortcut every single time? Well, if the scale starts with a 1, and if you're asked to find the actual distance or actual length, then yes, this shortcut of just multiplying will work every single time. But those are big ifs. The scale has to start with a 1. Spoiler alert, that's what it's going to start with every single problem on this packet of guided notes. And you have to be asked to find the actual distance or length. Okay, problem number 2. Hit pause in the video, try number 2 on your own, and then hit play when you're ready to see how you did. Okay, did you already do number 2 on your own? Here we go. We are asked to find the distance between Akron and Cleveland. We know that the distance on the map is 1.5 units. Now, what is the scale? Go ahead and circle it. The scale is that 1 unit is corresponding to 20 miles. So 1.5 units, we can multiply 1.5 times the 20 miles. I'm not pulling this out of thin air. It's right there in this scale given to me on the map. So 20 times 1.5 is going to give you an answer of 25 miles. Yes, I made this huge space on your notes, and really there isn't much work at all. So write down that little bit of work if you haven't already, and there is your answer. Okay, let's turn to the page. Finding actual area from a scale drawing. When you need to find the actual area, which, by the way, what that means is the area of the actual real life object or the real life room, if we're talking about blueprints of a floor plan, actual area first requires finding the actual length and the actual width. Now, this is very important. I would highlight this or underline this. You first have to get the actual length and the actual width. So not just the length and the width from the blueprint or from the scale drawing. You need to find out what is the actual length and the actual width. And the way you will do that is by using the given scale, just like we practiced on the previous page. After you have found the actual length and the actual width, well, then you can find the area. And if you're finding the area of a rectangle, A equals length times width will work nicely for area of a rectangle. By the way, I always use a cursive L for length because a printed L will look too much like a 1. So that's the only variable that I do make a lowercase cursive letter. Okay, let me show you what I'm talking about here. Let's do problem number 3 together. Using the scale drawing of a restaurant shown on the left, what is the actual area? Again, actual area, not the area on the drawing, but the actual area of the kitchen. So we want the actual area of the real life kitchen. We can see where the kitchen is. We can see it's 5 inches wide and 9 inches long. But what is the scale? Ladies and gentlemen, get your pencils ready. Here is the scale. Go ahead and circle it right there at the bottom of the blueprint. The scale is that every 1 inch equals 5 feet. Okay, so actual length, we need to take 9 inches and multiply it by 5 feet, because every 1 inch equals 5 feet. So we have 9 inches, so 9 times 5, you're writing this down, and we don't need a calculator for that. We know 9 times 5 is 45 feet. So notice that's feet, not inches, because every 1 inch equals 5 feet, so this is 45 feet. Now, for the actual width, we know it's 5 inches wide on the drawing, but every 1 inch is 5 feet. So we're going to take 5 inches times 5, because the scale told us 1 inch equals 5 feet, so times 5. And don't need a calculator for that, 25 feet. All right, do you have this written down? Now that we have the actual length and the actual width, we can simply do length times width to get the actual area. Now, don't go back to using 5 inches and 9 inches. Use the actual real length and real width that we just found. 45, and 25. Okay, feel free to use the calculator for this. 45 times 25, you probably don't know off the top of your head. Enter that into your calculator, and you're going to get 1,125. Now, notice area is not just feet. It is square feet. And the way that we symbolize that is putting a little 2 in the corner of the feet, because 2 means squared. Power of 2, another way of saying it is squared. So this is a fancy way of symbolizing square feet. And area is in squares. So you got to have square feet. Okay, now that I did, before I move on, some of you might be wondering, well, Mr. Underkoffler, do you get the same answer if you would find the area of the drawing first and then multiply that by the number found in the scale? Remember, the number found in the scale was that 1 inch equals 5 feet. Could I just do 5 times 9 and get the area of the drawing and then multiply that by 5? Well, I did the work here for you. We know 9 times 5 is 45, so that'd be 45 square inches. If I multiply that by the number in the scale, which was 5, do I get the same answer? No, not even close. So ladies and gentlemen, pencils in your hand. Write this down. This is a big, fat no. This is why my directions at the top of the page are very clear. You need to first find the actual length and the actual width. Use the scale to do that. Then after you've done that, then you multiply length times width to get the area. If you try to do it in the other order, it does not work. And if you're wondering why it doesn't work, it's because square feet is not the same as square inches. Regular inches is not the same as square inches. So that's why you can't switch the order here and expect it to work, because 1 inch equaling 5 feet does not mean 1 square inch equals 5 square feet. That's why reversing the order does not work. So stick with what we did. That does work. Okay, why don't you go ahead and hit pause, use this new blueprint, do number 4 and number 5 on your own, and then hit play when you're ready to see how you did. Oh, and make sure you're using the new scale. I believe I actually have these directions written above your blueprint if you're trying to find it on your paper. So make sure you're using this new scale, 1 inch equals 3 feet. Okay, so hit pause in the video, do 4 and 5 on your own, and then hit play when you're ready to see how you did. Okay, did you already do number 4 and 5 using the new scale for this blueprint, which is 1 inch equals 3 feet? If you did not, hit pause now. We want to find the actual area of bedroom 3. Okay, bedroom 3 is down here. We can see it's 4.5 inches long and it's 3 inches wide on the drawing. We need to multiply those numbers times 3 because 1 inch equals 3 feet. So 4.5 times 3, I would do 4.5 as 4.5. It's quicker to punch into your calculator that way. And that's going to give you 13.5 feet or 13.5 feet. You can keep it as a mixed number if you want. That's fine. 13.5, 13.5, same thing. For the width, 3 inches on the drawing, but we have to take that times 3 because 1 inch equals 3 feet. So 3 times 3, don't need a calculator for that. The width is 9 feet. So length times width, we're going to take 13.5 times 9, giving us an area of 121.5 or 121.5 square feet. Ladies and gentlemen, do you have square feet as your unit of measure? Problem number 5. This time you have to find the actual area of bedroom 1. This is problem 5. Bedroom 1 is here. We can see it's 3.25 inches long. How wide is it? Oh, the width here would be the same as the width down here. Oh, so that's where I get the width. The width of bedroom 2 is the same as the width of bedroom 1. So you have to be observant and see that this line segment here is the same as this line segment here, which is given to you as 3 inches. So that's our width of bedroom 1. So take 3.25 times the number in the scale, which is 3 feet, multiply, you will get 9.75 or 9.75 feet. Now, let's do the same thing for the width of 3 inches. Take that times 3 feet. Don't need a calculator for that. 9 feet. Area equals length times width. 9.75 times 9 is going to give you 87 3/4 or 87.75 square feet. Again, if you want to have this as a mixed number, 87 3/4, that would be fine. Totally acceptable. It is the same thing. Just make sure you have square feet for your unit of measure. Okay, problem number 6 on the next page. I should have told you to try this problem on your own as well. Now, this one is not area. This one is asking for the perimeter in feet of the actual triangle. So again, kind of like actual area, but perimeter is not length times width. Perimeter is taking the length of each side of the triangle and adding them together. So hit pause on the video, do number 6 on your own. Notice there is a scale, and then hit play when you're ready to see how you did. Okay, let's see how you did. Did you use the scale? We have 3 inches, but we know every inch is equal to 7.5 feet. So we're going to take 3 times 7.5, making this 22.5 feet. And then we have 2 inches for this diagonal. Take 2 inches times 7.5 feet, and that's going to give you a length of 15 feet. Now, there are 3 sides to the triangle. I just found out that the side that was 2 inches is actually 15 feet. I just found out that the side up here that was 3 inches is actually 22.5 feet. But what about this right side? What is that measurement? Well, let me show you something. If the angle, you might be like, well, angles aren't used for side measures. I know. Bear with me here. If this angle in this corner is y degrees, and this angle here in this corner is also y degrees, then this is an isosceles triangle. You're like, why should I care? Because it means the side on the left that touches that y degree angle and the x degree angle is going to be the same measure as the side on the right that also touches the y degree angle and the x degree angle. So even though I don't know what y is, I know y is the same as y. So that proves this is an isosceles triangle. So the left side is the same as the right side, which means this is also 15 feet. So you need to do 15 plus another 15, or 15 times 2, either way, and then finally add by the 22.5 feet. 3 sides of a triangle, 3 sides being added together to give you perimeter. If you messed up, feel free to hit pause and fix this now. When you add those, you're going to get 52.5 or 52.5 feet. Okay, let's finish these guided notes with kind of going backwards. Instead of asking us to find actual length or actual width or actual area or actual distance, we're going to switch it up. We're going to find now the drawing's length or the drawing's width, the drawing's dimensions from a given scale. Let me show you what I mean. Problem number 7. A room's actual dimensions, which means actual length and width, are 11 feet by 8 feet. Now, traditionally, we normally call the longer measurement the length and the shorter measurement the width. It doesn't really matter, though, if you flip-flop it. It doesn't really matter. That's the actual dimensions of the room. If the scale on the blueprint is 1 inch equals 4 feet, then what are the dimensions of the room on the blueprint? So we're switching it up here. Instead of getting the actual length and actual width, they're given to us. We're asked to find the length and the width on the actual drawing, on the blueprint. So you might have noticed we've been doing multiplication as a shortcut to get actual lengths, actual widths. But here we have to go backwards. So instead of multiplying by 4, can you guess what we're going to do? We're going to divide by 4. So we're going to take the actual length of 11 feet, divide by 4. Write this down. We're going to take the actual width of 8 feet. We're going to divide by 4. Write this down. Because this will give us the drawing's length and the drawing's width, or in the case here, a blueprint's length and a blueprint's width for this scale drawing. All right, calculator time. What is 11 divided by 4? It is 2.75. Now, The unit of measure on the blueprint is the drawing measurements unit, which is on the left on a given scale. So this is the drawings measurements. If you didn't remember that, this is at the very, very first page. Oh, there it is. I just passed it right here. They show you that the drawing measurement is on the left and the actual measurement is on the right. So let me go back to where I just was. Okay, boom. So I'm getting drawing measurements here, blueprint measurements. So that's 2 3/4 or 2.75 inches, and 8 divided by 4 is 2 inches. And if you would like to write the answer the same way it was given up here, something by something, feel free to do that. Now, you don't have to. You could have said 2.75 inches long. You could have said 2 inches wide. You could have said the length is 2.75 inches. You could have said the width is 2 inches. I don't really care which way you write this. What I do care is that you have the correct units of measure. And since we're getting the blueprint or drawings measurement, that's in inches, not feet. Problem number 8. The garden was 15 feet long, 10 feet wide. A scale drawing is created of the garden where the scale is 1 unit. Oh, you see they just switched it up on us here. Not 1 inch, 1 unit. So this is kind of like if you have a grid. Spoiler alert for problem number 9. 1 unit would be like, 1 length long on the box on a grid. So anyway, that's what 1 unit means. Equals 6 feet. How long and wide is the drawing of the garden? Okay, this is very similar to problem number 7. Hit pause in the video, similar work you saw in number 7, and then hit play when you're ready to see how you did. Okay, did you already finish number 8? You took 15 and divided by 6 because we're trying to get how long and wide the drawing of the garden is. So we're dividing instead of multiplying. 10 divided by 6 will give us the drawing's width. Using your calculator, 15 divided by 6 gives you 2.5. Now this is not inches. Look at the scale. It was 1 unit equals 6 feet. So this is 2.5 units long. And 10 divided by 6 is 1.6 repeating. So that's how wide it is. Now, if you would like to put the word by in between, like we did on problem number 7, this by this, you could do that. If you want to say the length is 2.5 units and the width is 1 2/3 units, you could. I really don't care how you answer this. I just care that you have the unit of measure being units for this problem. And by the way, 1.6 repeating could also be written as 1 2/3. Okay, the last 2 problems on the guided notes are going to have you take everything you just learned and put it together. Part A is going to ask for actual width and height. Remember the problems we did where we found actual lengths and actual widths? Look back at that work if you need to help you. Part B, though, gives you a new scale and is now asking for the width and height of the drawing. Similar to what we just did on problem number 7 and 8. So make sure you're paying attention to what the directions want you to find, because that's going to determine whether you're going to multiply to get your answer or whether you're going to divide to get your answer. So try number 9 and number 10. You are going to have to count spaces for units to help you figure out what you're going to multiply by to get the actual width and the actual height. Okay, I've set it up. Hit pause, do number 9, part A and part B, and then do number 10, part A and part B, and then hit play on the video once you are ready to see how you did for both parts of 9 and both parts of 10. Okay, did you already do number 9 and number 10? Let's see how you did. Part A, actual width and actual height. The width is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units wide. Did you take 12 times the number in the scale, 4.5? That's going to give you a width of 54 feet. For the height, it was 16. If you count, you'll get what I got. 16 units tall. 16 times 4.5 is 72 feet high. Part B. If the scale drawing is recreated on an index card using a scale of 1 unit equals 9 feet, what is the new width and height of the drawing? So this is kind of like number 7 and 8 that we did above. You're going to have to divide. Now you're going to have to take your answers from part A, which are the actual width and actual height, divide it by this new number in the scale. And that's going to give you the drawing's width and the drawing's height. Okay, same kind of work for number 10. Actual length, actual width. Now, we do have to count. We have 1, 2, 3, 4, 5, 6, 7 and a half long. We're going to take that times 50. And then it's 1, 2, 3, 4, 5, 6 units wide. So 6 times 50. 7.5 times 50 is 375. 6 times 50 is 300. There are your answers for part A. Feel free to hit pause if you need to fix whatever you had. Part B. And you still see my answers for part A over here in smaller print on the left. New scale is 1 unit equals 25 feet. What is the new length and the new width of the drawing? So we are dividing the answers we got from part A, dividing it by 25 from the new scale. That's going to give you the following answers. 15 units long, 12 units wide for the new drawing of the triangle that has this new scale. And that concludes the guided notes on scale drawings. Thank you for watching. We'll see you next time.